Hello there, and welcome to the Sleepy Scholar. Tonight's journey takes us into the vastness of space, to the ancient and wandering world of comets and asteroids. Long before our own world had settled into its quiet blue rhythm, the solar system was a grand and chaotic dance of dust and gas, a magnificent cloud slowly coalescing into the familiar shapes we know today. In that primordial dawn, countless silent travelers were born, forged from the leftover building blocks of creation. These are the comets and asteroids, the wandering remnants that have drifted through the cold, quiet dark for billions of years. They are the ancient storytellers of our celestial neighborhood, holding within their icy hearts and rocky mantles the deepest secrets of how everything began. They drift through the endless velvet of space not as mere rocks, but as time capsules, perfectly preserved from an age when the sun was young and the planets were just beginning to dream. To watch them is to watch the slow, majestic clockwork of the cosmos itself. Some of these wanderers hug the inner warmth of our star, tracing tight, predictable paths that we can chart with certainty, like faithful companions on an endless journey. Others are lonely voyagers, drifting in from the unimaginably distant reaches of the Oort cloud, gracing our skies only once every few thousand years before vanishing back into the deep dark, perhaps never to return. Tonight, we will follow their silent paths, riding along with these cosmic nomads as they sail through the magnificent stillness. We will explore their glittering icy tails, their varied and cratered surfaces, and the quiet, enduring roles they play in the grand tapestry of the universe. If you enjoy these quiet explorations, I invite you to like, subscribe, or share a thought below. It helps other curious minds find a place to rest. But for now, get comfortable. Let your eyes grow heavy. Let's begin. Asteroids and comets are the unmodified leftovers from the solar system's magnificent formation. Billions of years ago, before there was an Earth or a Mars, there was only a vast, swirling nebula of gas and primordial dust, slowly collapsing under its own immutable gravity. As the center ignited to form our sun, and the larger clumps gathered to become the majestic planets, countless smaller crumbs of creation were left drifting in the void. Unlike the planets, which grew hot and melted, changing their original nature, these smaller bodies have remained largely untouched since that very first dawn. They are pristine time capsules, drifting silently through the dark, holding within their rocky and icy hearts the original recipe of our celestial home, waiting patiently for us to read their ancient stories. The primary difference between a comet and an asteroid is mostly a simple matter of their birth location. In the early, chaotic days of our solar system, there was a theoretical boundary known as the frost line, located roughly between the current orbits of Mars and Jupiter. Inside this line, closer to the young sun's intense heat, fragile ices could not survive, and so only rock and metal coalesced into the sturdy, stoic asteroids. Beyond this line, in the deep cold of the outer system, ices of water, ammonia, and methane could freeze solid, allowing comets to form as vast, frozen worlds. It is a grand example of cosmic sorting, where mere distance from a star dictated the entire destiny of these billions of wandering worlds, separating them into realms of fire-forged stone and deep frozen ice. The Oort cloud is a theoretical colossal sphere of icy bodies that surrounds us at an unimaginable distance. Far beyond Pluto, beyond the Kuiper belt, lies this immense, spherical shell that marks the true, silent boundary of our sun's gravitational influence. It is so distant that it may stretch a significant fraction of the way to the next closest star, a realm of utter darkness and profound cold, where billions of comets sleep in a near-eternal orbit. They barely move, drifting in a delicate balance between our Sun and the gentle tug of the rest of the galaxy. It is the magnificent unseen nursery of long-period comets, a vast and quiet reservoir of frozen travelers that have waited there since the beginning of time, guarding the outermost gates of our solar system. The Kuiper Belt is a vast, donut-shaped ring of icy worlds that slowly circles just beyond the orbit of Neptune. Closer to home than the distant Oort cloud, this region is like a grander, icier cousin to the asteroid belt, filled with millions of frozen remnants from the grand construction of the giant planets. It is a cold, dark neighborhood, home to icy worlds like the dwarf planet Pluto and smaller objects such as Arakoth, worlds that have seen little warmth for billions of years. These objects drift in slow, stable rhythms, occasionally nudged by Neptune's gravity to journey inward toward the Sun. It stands as a sprawling, glittering hinterland, a quiet testament to the sheer scale of our system, where countless worlds exist in the long shadows of the giants. Ceres is the largest object in the main asteroid belt and was the very first asteroid ever discovered by human eyes. Back in 1801, astronomers were searching the empty darkness between Mars and Jupiter, convinced a missing planet must be hiding there in the vast gap. What they found was Ceres, a world so massive compared to its neighbors that its own gravity pulled it into a nearly perfect sphere. Unlike the lumpy, irregular shapes of most smaller asteroids, it is now classified as a dwarf planet, a lonely queen sitting on a throne of rock in the middle of the Great Belt. It contains vast amounts of water ice beneath its dusty crust, a silent, spherical world that bridges the gap between a mere rock and a true planet. A comet's magnificent tail only appears when it travels close enough to feel the warm embrace of the Sun. For most of its incredibly long life, a comet is merely a dark, quiet, dirty snowball, drifting invisibly through the deep freeze of the outer solar system. It is only when its long orbit carries it inward, crossing a certain invisible threshold of warmth, that the dormant ices on its surface begin to sublimate, turning directly from solid frozen ice into expanding gas. This glorious transformation releases trapped dust, creating a glowing, ethereal envelope around the nucleus called a coma. It is a beautiful metamorphosis, a silent wanderer suddenly blooming into one of the most spectacular sights in the heavens, all because it simply drew near to the light. Most visible comets actually have two distinct tails that stretch across the starry canvas of the night. When we see images of these celestial visitors, we often miss the subtle duality of their splendid display, created by different forces acting upon them. One tail is made of dust, heavier particles that gently curve behind the comet as it moves, tracing its path like a glittering memory. The second is the ion tail, made of electrically charged gas that is blown straight outward, always pointing directly away from the Sun, pushed by the relentless stream of the solar wind. Together, they form a majestic V-shape in the darkness, a delicate dual signature written by the Sun's invisible hand across millions of miles of empty space. Despite containing millions of tumbling rocks, the asteroid belt is incredibly empty and spacious. Movies often depict asteroid fields as crowded, chaotic jumbles of rocks that spaceships must frantically dodge to survive. In reality, the magnificent scale of space means that the asteroid belt is overwhelmingly composed of empty, quiet void. The average distance between significant asteroids in the main belt is roughly 600,000 miles, more than twice the distance between the Earth and the Moon. You could fly a ship through it 1,000 times blindly and never once come close to hitting anything. It is a testament to the humbling vastness of the cosmos, where even a region we call crowded is mostly a serene and endless ocean of nothingness. Astronomer Fred Whipple famously and affectionately described comets as dirty snowballs drifting through space. Before the mid-20th century, there was much debate about what these wandering apparitions actually were, with some thinking they might be loose banks of flying gravel. Whipple proposed they were solid nuclei, conglomerations of various frozen ices like water, carbon dioxide, and ammonia, mixed thoroughly with rock and cosmic dust. It was a humble but profoundly accurate description that revolutionized our understanding. These aren't just rocks, they are deep frozen reservoirs, ancient icy archives that have preserved the volatile breath of the young solar system, carrying it silently through the vacuum for eons. The massive, steady gravity of Jupiter acts as a grand shepherd for the entire asteroid belt. One might wonder why all that rock between Mars and Jupiter didn't just clump together to form another proper planet billions of years ago. The answer lies in giant Jupiter, whose immense gravitational tug constantly stirred the pot, speeding up the rocks and causing them to collide and shatter rather than gently coalesce. Jupiter also keeps the belt structured today, creating Kirkwood gaps, specific lanes in the belt that are kept completely clear of asteroids by the giant's rhythmic gravitational influence. It is the grand, silent guardian of the system, its invisible hand imposing a beautiful mathematical order on chaotic fields of rock. Halley's Comet has been a faithful and predictable visitor to Earth's skies for thousands of years of human history. It travels on a long elliptical path that brings it back to grace our inner solar system roughly every 75 to 76 years. This period beautifully and somewhat poignantly matches the average span of a human life, meaning most of us will see it only once, a singular cosmic marker in our personal timelines. It has been recorded by ancient Chinese astronomers, featured in the Bayeux Tapestry in 1066, and marked the birth and death of writer Mark Twain. It is a celestial pendulum, swinging through the centuries, connecting disparate generations of humanity who have all looked up in awe at the same wandering light. Many scientists think comets and water-rich asteroids may have been the cosmic delivery vessels for a significant portion of the water that now fills Earth's oceans. When the Earth first formed, it was likely a hot, dry, molten world, inhospitable and barren of the vast blue seas we know today. Theories suggest that during a chaotic early epoch, often called the Late Heavy Bombardment, countless icy comets and water-rich asteroids rained down upon our young world. They were not just bringers of impact, but bringers of life's most precious ingredient, their frozen cargo melting over millennia to form the first seas. It is a beautiful thought that the water in your glass may have once ridden on a comet from the furthest, darkest reaches of the solar system to reach you. Beyond mere water, these wanderers also carry the complex organic building blocks necessary for life. Scientists studying meteorites, pieces of asteroids that have fallen to Earth, have found them surprisingly rich in amino acids and other complex carbon-based molecules. These are not life itself, but they are the essential seeds of chemistry that life uses to build itself. It paints a picture of comets and asteroids as celestial sowers, drifting between worlds and potentially dropping the raw ingredients of biology onto barren planets. It suggests that the potential for life might not be a unique miracle of Earth, but a natural, quiet blooming that is seeded throughout the entirety of the cosmos. The asteroid impact that ended the long age of dinosaurs was a pivotal moment of transformation for life on Earth. About 66 million years ago, a massive object, likely roughly 10 kilometers wide, struck what is now the Yucatan Peninsula in Mexico. While it brought a dramatic close to the magnificent reign of the great reptiles, it was also an act of grand cosmic clearing. This event opened unparalleled new ecological spaces for tiny, warm-blooded mammals, our distant ancestors, to thrive, diversify, and eventually gaze back at the stars. It is a powerful reminder that in the grand geology of time, such events are not merely endings, but necessary violent turning of the pages that allow new and wondrous chapters of life to be written. The giant planet Jupiter is accompanied in its majestic orbit by two massive clouds of Trojan asteroids. These are not renegade rocks, but faithful companions that have been trapped by Jupiter's gravity in stable regions called Lagrange points. One great cloud marches always 60 degrees ahead of Jupiter, and another identical cloud trails always 60 degrees behind it. They have been locked in this grand celestial formation for billions of years, unable to leave their gravitational parking spots. They are like an honor guard for the king of planets. Thousands of silent outriders eternally escorting the gas giant on its endless journey around the sun. The beautiful meteor showers we watch annually are actually the ancient, dusty trails left behind by comets. As a comet travels near the sun and sublimates its ice, it leaves behind a vast stream of tiny dust particles, like breadcrumbs marking its path through the dark. When Earth's yearly orbit intersects one of these invisible streams, the dust particles strike our atmosphere at tremendous speed and burn up as harmless, brilliant streaks of light. The Perseids in August, the Leonids in November. These are humanity sailing through the ghostly, glittering wake of a comet that may have passed by decades or even centuries ago, a beautiful echo of a past visitor. In 2017, humanity detected its very first confirmed visitor from completely outside our own solar system. Named Oumuamua, a Hawaiian term meaning scout or messenger from afar. This object was moving too fast and on too strange a seemingly hyperbolic trajectory to have originated from our own sun's family. It was a strange, elongated, dark red object, tumbling silently end over end as it plunged through our inner solar system and then sped back out into the interstellar void, never to return. It was a poignant reminder that our solar system is not an isolated island, but sits in a vast, connected ocean, where silent ships from other stars occasionally pass in the endless night. Humanity has successfully sent gentle robotic envoys to touch the surface of asteroids and bring pieces back home. Missions like the Japanese Hayabusa probes and NASA's OSIR-ISR-EX have performed incredible feats of delicate navigation. They traveled millions of miles to match the speed of spinning, irregularly shaped rocks with almost no gravity, gently tagging the surface to collect pristine dust before flying all the way back to Earth. These tiny capsules dropping into our deserts have allowed us to hold the primordial dust of the solar nebula in our own hands. It is a quiet triumph of curiosity, reaching out across the void to touch the ancient past physically. Many asteroids are not traveling through the dark alone, but are accompanied by their own tiny moons. For a long time, astronomers believed only major planets were grand enough to have moons of their own. This assumption was shattered when the Galileo spacecraft, passing the asteroid Ida in 1993, discovered a tiny, mile-wide moonlet named Dactyl, quietly orbiting it. Since then, we have found hundreds of such systems, including binary asteroids, where two rocks of roughly equal size slowly waltz around each other in the void. It shows that gravity's tendency to pair objects together in a delicate dance happens at every scale, from the mightiest stars down to the humblest tumbling rocks. There are currently over 1 million known asteroids, and likely millions more still waiting in the dark. We are constantly finding new members of this vast population, ranging from dwarf planets nearly 600 miles across down to small boulders just a few feet wide. They are arguably the most numerous citizens of our solar system, far outnumbering the planets and moons we are most familiar with. While the planets may be the brilliant jewels of the Sun's family, these countless legions of silent, drifting rocks are the true vast majority, each one carrying its own billions of years of quiet, undisturbed history as it sails through the endless vacuum. In 1994, humanity witnessed a rare and magnificent celestial drama as Comet Shoemaker-Levy 9 collided with Jupiter. Usually, cosmic impacts happen over geological timescales, separated by millions of quiet years, leaving us only ancient craters to study as silent echoes of the past. But this time, we watched in real time as a comet, already broken into a beautiful string of pearls by Jupiter's immense gravity on a previous pass, returned for a final spectacular embrace with the giant planet. Over several days, 21 distinct fragments plunged into Jupiter's thick, swirling atmosphere, not with a whimper, but with tremendous releases of energy that created vast, dark scars in the cloud tops visible even in smaller telescopes from Earth. These dark bruises, larger than our entire planet, lingered for months, slowly fading like ink dispersing in a vast, churning ocean of gas. It was a humbling reminder of the dynamic, ever-changing nature of our solar system, a grand show put on by the cosmos that highlighted majestic forces far greater than ourselves. Some asteroids, like the diamond-shaped Bennu, are not solid rocks, but delicate rubble piles, held together by nothing more than weak gravity. We often imagine asteroids as dense, monolithic slabs of solid stone tumbling through the void, much like mountains floating in space. However, many are actually far more fragile, composed of millions of smaller rocks, pebbles, and dust grains that have slowly drifted together over eons, clustering like a loosely packed snowball. If you were to step onto the surface of such a world, you might sink slightly into the loose regolith, as there is barely enough gravity to keep the magnificent pile from drifting apart back into individual motes of dust. They are tenuous, gentle worlds, ancient collections of debris that have managed to stay together through the sheer persistence of mutual attraction over billions of quiet years. There is a family of comets known as sun-grazers that are destined to dive spectacularly close to the solar surface. Most belong to the Kreutz group, believed to be the shattered remnants of one massive ancient comet that broke apart centuries ago, creating a legion of smaller icy fragments on identical perilous paths. These brave travelers swing incredibly close to our star, sometimes passing within mere thousands of miles of its roaring, superheated surface. While many of these tiny voyagers are vaporized completely in that intense furnace, vanishing in a final, brilliant flash of glory, the larger ones sometimes survive, emerging from the sun's blinding glare with bright, freshly replenished tails, It is a daring cosmic dive, a moth drawn to the ultimate flame, playing out in a grand, silent loop for millennia. Vesta is unique among the millions of asteroids because it is occasionally bright enough to be seen from Earth with the naked eye. While almost all other asteroids are too small or too dark to be more than invisible specks without powerful telescopes, Vesta has a uniquely reflective surface, likely made of basaltic rock that gleams faintly in the sun's distant light. Under perfectly dark, moonless skies, far from city lights, a keen-eyed observer might just spot it as a vanishingly faint, wandering star, slowly shifting its position night after night against the fixed backdrop of the Milky Way. It is a rare and subtle connection, a moment where one of these distant lonely worlds becomes just visible enough to be registered by human sight without aid, a tiny silent spark in the immense dark. The hypothesis of Panspermia suggests that comets might be the grand arcs that ferry life between star systems, beyond just carrying water or simple amino acids to Earth. Some thinkers wonder if incredibly resilient microscopic life could actually survive the deep freeze inside a comet's icy heart. In this majestic view, life does not need to miraculously begin anew on every habitable world. Instead, it might only need to start once, thereafter hitchhiking on comets that get ejected from their home systems to drift for eons across the interstellar deserts. If true, comets would be like cosmic dandelion seeds, drifting on the galactic winds, waiting to land on a fertile new world to wake from their billion-year slumber and begin the grand story of evolution all over again under a new sun. Throughout human history, great comets have appeared unexpectedly, shining brighter than the brightest stars. These are rare and overwhelmingly beautiful visitors that arrive perhaps only once or twice in a century, becoming so intensely brilliant that they can sometimes even be seen during pure daylight. They hang in the sky like vast, glittering swords or fiery bridges, dominating the nights for weeks and filling entire civilizations with a profound sense of awe and wonder. Before we understood their icy nature, they were seen as omens or divine messengers, changing the course of wars and the decisions of emperors simply by their silent, majestic presence. Today, we understand their physics, yet the sheer visual glory of a great comet stretching across the heavens remains an unmatched, humbling spectacle that unites the world in upward-gazing reverence. The asteroid Psyche appears to be the exposed solid metal core of a planet that never finished forming. Most worlds we know are covered in rock, ice, or gas, hiding their dense metallic hearts thousands of miles beneath distinct layers. Psyche, however, is a rare window into the deep interior of a world, likely the leftover remnant of a violent hit-and-run collision billions of years ago that stripped away all its outer rocky mantle. It is a world made largely of iron and nickel, a naked, shimmering core drifting through the darkness between Mars and Jupiter. It offers us a chance to effectively journey to the center of a planet without ever having to dig. A frozen, metallic echo of a world that was almost, but never quite, born. Comets sometimes undergo sudden, unpredictable outbursts, brightening dramatically in a matter of hours, while their usual brightening as they approach the sun is a slow and steady curve. Occasionally, they will flare up with intense, unexpected brilliance, appearing hundreds or thousands of times brighter overnight. This is thought to be caused by pressurized pockets of gas deep within their icy nuclei, suddenly finding a weak spot and bursting forth, like a geyser erupting into the vacuum of space. These grand exhalations throw vast clouds of fresh reflective dust into the coma, temporarily turning a faint, sleepy comet into a dazzling jewel before it slowly settles back down into its quiet, steady rhythm of sublimation. Earth occasionally captures tiny temporary minimoons from the near-Earth asteroid population. We tend to think of our moon as our only faithful natural satellite, but every now and then, a small asteroid, perhaps only a few feet across, drifts too close and gets caught in Earth's delicate gravitational web. These visitors might loop around our planet in complicated, unstable orbits for a few months or even a few years, silent, unnoticed companions on our journey around the Sun. Eventually, the complex tug-of-war between Earth and the Sun flings them back out into their own independent orbits, and they resume their lonely wanderings, having briefly shared our home in the vastness of space. If you could smell a comet, it would have a strangely distinct and pungent aroma due to its complex chemistry. Instruments sent to rendezvous with comets, like the Rosetta mission, analyze the glorious cocktail of gases gently venting from the surface. They found traces of hydrogen sulfide, which smells like rotten eggs, ammonia, reminiscent of strong cleaning products, and hydrogen cyanide, which is said to smell faintly of bitter almonds. While it might not be a pleasant perfume to human senses, it is a fascinating chemical signature, a complex recipe cooked up in the solar nebula billions of years ago. It is the true scent of deep space, a primordial odor that has been locked away in ice since before the Earth was formed. A subtle force, called the Yarkovsky effect, slowly pushes asteroids off their original paths over millions of years. This is not a violent push, but an incredibly gentle nudge caused by mere sunlight. As an asteroid spins, the side facing the Sun warms up, and when that warm side rotates into the dark, it radiates that heat back out into space as thermal photons. This tiny, continuous emission of heat acts like an unimaginably faint thruster, slowly drifting the asteroid's orbit over eons. It is a beautiful example of how even the softest, most intangible touch of light, when applied over the immense scales of cosmic time, can move mountains through the dark. Centaurs are strange celestial hybrids that drift in the chaotic region between Jupiter and Neptune, named after the mythical half-human, half-horse creatures. These objects share characteristics of both asteroids and comets, defying easy classification. They likely originated in the deep freeze of the Kuiper Belt, but were nudged inward, where they now wander precariously among the giant planets. Because they cross the orbits of immense worlds like Saturn and Uranus, their paths are unstable, and they will eventually be ejected from the solar system entirely, or thrown inward to become comets. They are transient ghosts, caught in a cosmic way station, slowly transitioning from the quiet dark of the outer system to the bright warmth of the inner system. NASA's Stardust mission used a wondrous substance called aerogel to catch comet dust without harming it. To bring back samples from a comet's tail, scientists couldn't just use a solid net, as the tiny particles moving at tremendous speeds would vaporize instantly upon impact. Instead, they used aerogel, a ghostly, nearly weightless blue silicon foam that is 99.8% air, the lightest solid ever created. When the comet dust hit this frozen smoke, it slowed down gradually, burying itself intact within the delicate foam, like a tiny insect trapped in amber. It allowed us to capture pristine grains of the early solar system with the gentlest possible touch, preserving their fragile structures for study back on Earth. While Jupiter has the most famous Trojan asteroids, other planets have their own smaller retinues of loyal followers. Neptune, the distant blue giant, has been found to have dozens of known Trojans, and it likely possesses many more that are too faint for us to easily see from so far away. Even Mars, our close rusty neighbor, is accompanied by a handful of these stable companions, and Earth itself has at least 2 known tiny Trojans sharing our orbit. It seems to be a universal harmonious pattern, where wherever a massive planet establishes a stable gravitational rhythm, small, obedient rocks will eventually find their place in the grand procession, marching in lockstep with their larger masters. The snow line in a solar system is not a fixed location, but a boundary that slowly moved over time. When our sun was young and burned hotter or cooler during different phases of its violent youth, the invisible line where water could freeze solid drifted inward and outward like a tide. This means that the regions where different types of asteroids and comets formed were not static but dynamic, shifting zones of creation. Objects that formed in one location might have been baked dry later, while others remained forever frozen. The current arrangement of dry inner asteroids and icy outer comets is just a frozen snapshot of where that shifting thermal boundary happened to be when the dust finally settled. Some objects that look like asteroids today might actually be extinct comets that have lost their shine. After thousands of passes around the Sun, a comet may eventually exhaust all its accessible surface ice, having sublimated it all away into brilliant tails over the millennia. What remains is a dark, quiet husk of rock and dust that no longer develops a coma, effectively retiring from its spectacular life as an active comet to become just another tumbling stone, indistinguishable from a regular asteroid. It is a peaceful retirement, wandering quietly in the dark after eons of brilliant, fiery displays, a celestial veteran resting after a long life of magnificent transformation. A very rare few asteroids orbit the Sun in retrograde, moving in the complete opposite direction to everything else. Almost every major object in our solar system, planets, moons, and the vast majority of asteroids, orbits the Sun counterclockwise, retaining the original spin of the primordial nebula. However, a handful of renegade rocks travel clockwise against the massive flow of cosmic traffic. These are likely captured objects from interstellar space or visitors from the very distant Oort cloud that were flipped into strange orbits by close encounters with Jupiter. They are the lonely nonconformists of the system, eternally sailing against the current in a grand, solitary display of cosmic defiance. The distant asteroid Chariklo was surprisingly discovered to have its own delicate system of rings. We usually think of rings as the exclusive majestic jewelry of giant planets like Saturn, vast structures made of billions of icy particles. But Chariklo, a mere 160-mile wide rock drifting between Saturn and Uranus, possesses 2 dense, narrow rings of its own. It was a stunning revelation that such a small, lumpy world could maintain such delicate, orderly structures around it. It suggests that rings might be far more common than we ever dreamed, ephemeral features that can grace even the humblest of worlds, adorning them with their own tiny, private halos in the deep dark. The Tunguska event of 1908 was likely caused by a small asteroid or comet fragment that exploded before hitting the ground. Over a remote region of Siberian forest, a massive explosion flattened some 80 million trees over an area of 800 square miles, all without leaving any substantial impact crater. It is believed the incoming object, perhaps 50 to 100 meters across, couldn't withstand the intense pressure of our atmosphere and detonated in a magnificent airburst miles above the surface. The shockwave circled the Earth twice, a grand, impermanent announcement of its arrival that left no lasting scar on the Earth's crust, only a vast, flattened forest that has since slowly regrown, green and quiet once more. We have charted the future paths of potentially hazardous asteroids and found that Earth faces no known impact threat from any large asteroid for at least the next century. There was once great fear surrounding the asteroid Apophis, which will make a spectacularly close pass to Earth in 2029, coming closer to us than our own geostationary satellites. However, refined measurements have confirmed it will safely sail on by, offering a magnificent, once-in-a-lifetime viewing opportunity rather than a threat. It is a testament to our growing understanding of the cosmic clockwork that we can now look ahead for decades with certainty, replacing ancient fears of the unknown with the calm assurance of precise, predictable celestial mechanics. Tiny, glassy beads found inside primitive asteroids are among the oldest solid materials ever discovered in our solar system. These minute spheres, known as chondrules, are the primordial seeds of celestial geology, formed before Earth or even the Sun had fully stabilized into their current forms. They were likely created in the intense, transient, flash-heating events of the early solar nebula, where freely floating dust was instantly melted into liquid droplets that then froze rapidly in the cold vacuum of space. Billions of these tiny, solidified droplets eventually drifted together, gently coalescing to form the very first asteroids, locking these pristine moments of creation inside larger bodies of rock. To hold a meteorite containing chondrules is to hold the very first hardened teardrops of the newborn solar system, little kernels of deep time that have remained unchanged for over 4.5 billion years. Strange and beautiful magnetic songs have been heard singing from comets as they travel through the void. When the Rosetta spacecraft rendezvoused with Comet 67P, its instruments picked up a fascinating, rhythmic oscillation in the comet's magnetic field. It was not sound as we know it, for space is a silent vacuum, but rather complex interactions between the solar wind and the comet's own outgassing atmosphere that created magnetic waves at frequencies just below human hearing. When shifted into our audible range, it sounds like a strange, warbling, otherworldly choir, a bubbling and clicking song of plasma. It is a beautiful reminder that the universe is full of silent symphonies, complex and rhythmic interactions of energy that play out continuously across the dark, only waiting for us to build the right ears to finally hear them. Despite containing millions of distinct objects, the total mass of the entire asteroid belt is surprisingly small. If you were to magically gather every single asteroid, from massive series down to the smallest drifting pebble, and crush them all together into a single object, the resulting world would still be significantly smaller than our own moon. It is a humbling realization that all that vast debris, spread out over such an unimaginably immense volume of space between Mars and Jupiter, amounts to mere crumbs left over from the solar system's main meal. It reinforces the idea of space as overwhelmingly empty, a grand and quiet ocean where these few, widely scattered islands of rock drift in near total isolation, their collective presence a mere whisper compared to the shouting mass of the major planets. The nuclei of comets are among the absolute darkest objects known to exist in the entire solar system. We see them from Earth as brilliant, glowing spectacles because of the vast clouds of reflective gas and dust they release when heated. However, if you were to visit a dormant comet far from the Sun, you would find its surface to be blacker than fresh asphalt or charcoal. They are coated in complex, dark organic compounds and ancient cosmic dust that absorb almost all the starlight that falls upon them. They are essentially deep black phantoms drifting against the black background of space, visible only when they occult a distant star, perfect camouflage travelers hidden by the very darkness they traverse until the sun's warmth forces them to reveal their brilliant inner nature. A faint, ghostly glow, known as the zodiacal light, is actually sunlight reflecting off ancient comet dust. If you look toward the horizon just after twilight fades, or just before true dawn begins, under perfectly dark skies, you might see a tall, diffuse triangle of soft white light stretching up from the sun's position. This ethereal pillar is not from Earth's atmosphere, but is created by countless trillions of microscopic dust grains drifting in the inner solar system, many of which were shed by comets over billions of years of quiet passages. It is literally the accumulated, glittering history of countless ancient travelers, a tenuous, dusty disk that allows us to see the plane of our solar system illuminated from within by the gentle scattering of starlight. Earth is accompanied in its annual journey by a small, faithful Trojan asteroid named 2010 TK7. Just as mighty Jupiter has its vast clouds of Trojan followers, our own blue planet has managed to capture a few tiny companions in its own gravitationally stable Lagrange points. This particular asteroid, perhaps only a few hundred meters across, dances securely about 60 degrees ahead of Earth in our orbit, leading the way around the Sun. It has likely been there for centuries or longer, a silent, unobtrusive escort that never draws any closer to us, content to maintain its respectful distance while sharing our grand voyage through the cosmos. It is a gentle reminder that even on our solitary yearly path, we are not entirely alone. The names we give to space rocks change depending on which stage of their grand journey they are currently in. When a piece of rock or dust is purely drifting in space, it is called a meteoroid, a silent wanderer of the void. When that same rock enters Earth's atmosphere and burns brightly as a shooting star, it becomes a meteor, a brief and brilliant flash of incandescent glory. And if any part of it survives that fiery trial to gently touch the ground, it is christened a meteorite, a permanent new resident of our planet. It is a beautiful linguistic evolution that honors the dramatic transformation these objects undergo, from silent voyagers of the infinite dark to tangible stones we can hold in our own hands. Japanese scientists on their Hayabusa 2 mission gently created an artificial crater on an asteroid to see what lay beneath its weathered skin. To understand the pristine interior of asteroid Ryugu without waiting billions of years for a natural collision, the spacecraft released a small, precise impactor made of copper. It struck the surface while the main probe watched safely from a distance, excavating fresh material that had been shielded from the harsh solar wind for eons. The spacecraft then delicately descended to scoop up this freshly exposed time capsule material. It was a magnificent feat of gentle cosmic archaeology, allowing us to peer beneath the dusty pages of history to read the perfectly preserved text of the early solar system written in the rock below. Jupiter acts as a massive gravitational shield, protecting the inner planets from many potential cometary visitors. Its immense gravity well, the deepest in the solar system besides the Sun itself, acts like a gigantic cosmic vacuum cleaner or a gravitational slingshot. Many comets that fall inward from the Oort cloud are either swallowed whole by the gas giant, just like Shoemaker-Levy 9, or are flung violently completely out of the solar system before they ever get close to Earth. Without this silent, massive guardian patrolling the outer reaches, our tranquil blue world might have experienced far more frequent and chaotic impacts throughout its long history. It is the grand, unsung protector of our calm little corner of the galaxy. Comet Encke is a surprisingly frequent visitor, holding the record for the shortest orbital period of any known comet. While many of its icy cousins take thousands of years to complete a single lonely loop, little Comet Encke rushes back to the inner solar system every 3.3 years. It has been trapped by gravity into this tight, surprisingly stable little path, becoming a regular local resident rather than a distant traveler. Because it passes the Sun so often, it has shed much of its volatile ice over the millennia and now puts on a fairly modest, quiet display. It is like an old, familiar friend who visits often, worn down by time but faithful in its endless, predictable rounds. There is a strange class of objects called active asteroids that blur the supposedly clear line between comets and rocks. These objects have orbits that sit firmly within the main asteroid belt, where things should be dry and rocky, yet they occasionally and mysteriously sprout comet-like tails. Sometimes this is due to a slow-motion collision exposing buried ice that suddenly sublimates, or perhaps it is because they are spinning so fast that dust is simply drifting off their surfaces into space. They are fascinating rule breakers that remind us nature rarely adheres to rigid human categories, preferring instead a beautiful, messy spectrum of possibilities where rocks can sometimes act like comets if the conditions are just right. The Murchison meteorite, which fell in Australia in 1969, smelled distinctly of damp asphalt and aromatic organic compounds. When scientists analyzed this fresh arrival from the asteroid belt, they were stunned to find it was incredibly rich in complex carbon chemistry, including dozens of different amino acids, the very building blocks of proteins. It was a profound confirmation that the chemistry necessary for life is not unique to Earth, but is cooked up naturally in the cold, dark crucibles of asteroids billions of miles away. It means the raw ingredients for biology are likely common throughout the entire universe, just waiting for a warm, wet world to fall upon and take root. The Vredefort crater in South Africa is the oldest and largest visible impact scar remaining on Earth's surface. Formed roughly 2 billion years ago by an asteroid estimated to be 10 to 15 kilometers wide, the original crater was colossal, perhaps 300 kilometers across. Over incredibly vast stretches of geological time, wind, rain, and plate tectonics have eroded much of the original rim, leaving behind only a ghostly, persistent ring of hills and unique geological formations. It stands as a silent, deeply eroded monument to the violent energies of the early solar system, a scar that has slowly healed over eons until it has become just another beautiful, quiet part of the Earth's ancient landscape. Comet Neowise recently gifted humanity with one of the brightest cometary displays in decades during the summer of 2020. For several weeks, it was easily visible to the naked eye, even from light-polluted cities, hanging motionless in the evening twilight, like a delicate smudge of white chalk on a dark board. It became a shared global experience during a difficult time, a peaceful celestial visitor that millions of people across the planet stepped outside to watch together. Having now swung past the sun, it has begun its long, silent journey back to the outer dark and will not return to our skies for nearly 7,000 years, leaving only photographs and memories of its brief, beautiful visit. Future generations may look to asteroids not just as scientific curiosities, but as vast, untapped resources floating in the dark. Many asteroids are incredibly rich in precious metals like platinum, nickel, and cobalt, containing more of these materials in a single small rock than has ever been mined in all of human history. Others are rich in water ice, which could one day be melted to provide drinking water and breathable oxygen for future deep space travelers. It paints a vision of a future where these drifting rocks become the stepping stones for humanity's expansion, grand, silent fueling stations and treasure chests, waiting patiently in the void for us to arrive. The true scale of the Oort cloud, the distant home of long-period comets, is almost impossible to humanly comprehend. It is estimated to begin far beyond Pluto and stretch perhaps a significant fraction of the way to Alpha Centauri, the nearest star system to our own. This means our sun's gravitational influence extends incredibly far, holding on to these tenuous frozen comets across a span of light years. It is a spherical, colossal shell of sleeping worlds that wraps our entire solar system in a vast, icy embrace, marking the true, silent frontier where our home ends and the endless interstellar ocean truly begins. Not all objects in the distant Kuiper belt are the same color. They display a wondrous, subtle diversity of hues. While one might expect everything in the deep freeze to be uniformly gray, telescopes have revealed that these icy worlds range from dark, neutral slate grays to deep, rich, reddish browns. This variation is likely due to different mixtures of ancient organic compounds, complex tholins, that slowly redden over billions of years under the faint, relentless bombardment of cosmic rays. It means the outer solar system is not just a monochrome dark, but a subtly colorful place, a vast gallery of ancient frozen worlds, each painted with its own unique chemical history. Eventually, in the unimaginably distant future, every comet will either be destroyed or ejected forever. Comets are, by their very nature, temporary phenomena in the grandest scales of cosmic time. Each time they pass the sun, they lose a small part of themselves to the glorious tales we admire, slowly wasting away until nothing is left but a rocky ghost. Others will eventually have a close encounter with Jupiter that flings them out of the sun's grip entirely, sending them sailing alone into the galaxy. It means the magnificent displays we enjoy today are a passing phase in the life of the solar system, a long, beautiful chapter that will eventually, quietly, come to an end. Some asteroids have orbits so eccentric they cross the paths of several inner planets. These daring travelers, many belonging to the Apollo or Aten families, do not stay safely confined to the main belt, but swing inward, threading their way past worlds like Mars, Earth, Venus, and sometimes even Mercury. They live dangerous, dynamic lives, constantly tugged by the gravity of the worlds they pass near. They are the cosmic weavers, threading the needle between the stable planets, linking the disparate parts of the inner solar system together with their long, looping, and sometimes perilous journeys through the dark. Comet tails can sometimes completely detach from the main body in a spectacular event called a disconnection. This dramatic change happens when a comet travels through a sudden shift in the solar wind's magnetic field. The complex magnetic forces can essentially snip the ion tail off, causing it to drift away freely into space like a piece of ribbon caught in a breeze. Remarkably, the comet will soon grow a brand new tail to replace the lost one, continuing its display undaunted. It is a grand visual reminder of the invisible, tumultuous sea of charged particles that floods our solar system, a sea whose changing currents we can only see when they tear at the delicate veils of a passing comet. In 1996, Comet Hyakutake surprised the world not just with its sudden brightness, but with a tail that stretched across a staggering portion of the solar system. While we often marvel at comet tails that stretch across our evening sky, Hyakutake's true scale was invisible to our eyes and only revealed by a distant spacecraft. The Ulysses probe, which was orbiting far above the Sun's poles, unexpectedly flew through Hyakutake's invisible ion tail, more than 350 million miles away from the comet's actual nucleus. It revealed a structure of unimaginable scale, a tenuous, electrically charged stream of particles stretching longer than the entire distance between the Earth and the Sun. It is breathtaking to realize that such a tiny, unassuming ball of dirty ice can unfurl a majestic, invisible banner that quietly spans such an immense fraction of our entire celestial neighborhood without us even noticing from the ground. Every single day, Earth is gently dusted by roughly 60 to 100 tons of tiny cosmic material from comets and asteroids. We tend to only notice the arrival of space rocks when they blaze spectacularly as meteors. But the vast majority of celestial material arrives in absolute silence. These are micrometeorites, tiny grains of ancient dust, often no larger than a grain of sand or a speck of smoke, that drift slowly down through the atmosphere like a constant, invisible snow. They land everywhere, in our oceans, on our rooftops, and in the remote ice of Antarctica, slowly, imperceptibly, adding to the mass of our planet over billions of years. It means that we are all, quite literally, walking on a thin dusting of stars, surrounded constantly by the quiet, ancient debris of the solar system's ongoing construction. The strange, two-lobed shape of Comet 67P/Churyumov-Gerasimenko reveals a gentle cosmic merger from the distant past. When the Rosetta spacecraft first approached this comet, scientists were stunned to see it looked remarkably like a giant rubber duck, with two distinct lobes connected by a thinner neck. This odd shape likely formed billions of years ago, when two completely separate, slow-moving icy objects drifted toward each other in the early solar nebula. Instead of a violent, shattering collision, they met with a delicate, stony kiss, gently fusing together under their weak mutual gravity to become a single, united world. It stands as a frozen monument to the incredibly slow and gentle processes that built our system, a celestial embrace that has lasted for over 4 billion years. Astronomers have identified dozens of distinct asteroid families that are the shattered remnants of larger, ancient parent worlds. Millions or billions of years ago, large precursor asteroids were struck by other massive objects, shattering them into vast clouds of smaller fragments that continue to travel together along similar orbital paths. By carefully mapping the orbits of modern asteroids, scientists can mathematically rewind the clock, tracing thousands of seemingly unrelated rocks back to a single point of origin in regular space and time. These families are the ghostly echoes of worlds that no longer exist, vast swarms of siblings still traveling together through the dark, silently carrying the genetic orbital signature of the single great parent body from which they were all born. Comets experience strange and extreme seasonal changes as they travel along their highly elliptical orbits. Unlike Earth's mild and predictable seasons, a comet's summer is a brief, intense period of fierce heating and spectacular activity during its close flyby of the Sun. This is followed by a winter that can last for centuries or even millennia, a time of unbelievably deep freeze where the comet travels through the utter blackness of the outer solar system, completely dormant and silent. These worlds exist in a state of near-eternal hibernation, punctuated only by brief, frantic moments of awakening where they shed their skins and shine, before returning once more to the long, cold sleep of the distant void. Sunlight can act as a gentle, persistent turbine that causes asteroids to slowly spin faster and faster over time. This phenomenon, known as the YORP effect, occurs because asteroids are irregular shapes that absorb and re-radiate sunlight unevenly across their varied surfaces. Over millions of years, this incredibly tiny imbalance in thermal radiation acts like a persistent phantom hand, gradually torquing the asteroid and increasing its rotation rate. Eventually, this gentle push of light can spin a rock so fast that it can no longer hold itself together against centrifugal force, causing rocks to drift off its equator or even splitting the entire asteroid in two. It is a marvelous demonstration of how mere light, given enough time, becomes a geological force capable of reshaping solid worlds. NASA's Deep Impact mission in 2005 deliberately steered a probe into a comet to reveal its hidden interior. To see what lay beneath the dark, weathered crust of Comet Tempel 1, scientists sent a washing machine-sized impactor to collide with it at high speed, while a second spacecraft watched from a safe distance. The resulting impact did not destroy the comet, but merely puffed out a brilliant, surprisingly fine cloud of powdery dust and ancient ice, creating a fresh crater for study. It was humanity simply scratching the surface of an ancient wanderer, a gentle, inquisitive knock on a celestial door, to ask what ancient secrets were locked away inside its frozen heart. The dust that makes up a comet is incredibly fluffy, far less dense than even freshly fallen snow on Earth. We might imagine comet dust as gritty sand, but analysis from various missions has shown it to be complex, porous aggregates of microscopic grains held together by the frailest of forces. Some of these particles are so delicate that they are almost like cigarette smoke or airy tufts of dandelion fluff that just happen to be made of stone and carbon. If you could hold a clump of this primordial material in your hand on Earth, it might crush under its own almost non-existent weight, a fragile celestial gossamer that has somehow survived the harsh environment of space for eons. The naming of asteroids is a grand, collaborative human endeavor that honors everything from mythology to modern musicians. While comets are traditionally named after their discoverers, asteroids offer a vast canvas for human creativity once their orbits are securely determined. There are asteroids named after brave astronauts, beloved, kindly teachers, famous rock stars, and even mythological concepts like Justicia or Paciencia. It transforms the desolate catalogue of spinning rocks into a rich cultural tapestry of humanity, projecting our heroes, our values, and our whimsy out into the eternal darkness, ensuring that these names will circle the sun long after their earthly memory has faded. The nice model of solar system evolution suggests a magnificent chaotic migration of the giant planets long ago. It is believed that the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form where they are today, but slowly drifted, occasionally engaging in gravitational dances that radically shifted their orbits. This grand rearrangement would have sent immense gravitational shockwaves through the ancient asteroid and Kuiper belts, scattering billions of small rocks like leaves in a sudden autumn gale. The quiet, orderly solar system we see today is likely the settled aftermath of this majestic, tumultuous youth, a peaceful garden that grew from a wild and dynamic scattering of ancient seeds. In 1910, while the world was eagerly awaiting the famous return of Halley's Comet, another visitor stole the show. Unexpectedly, a completely different comet, now known as the Great Daylight Comet of 1910, appeared just months before Halley and became so brilliantly bright that it was visible immediately next to the Sun in the high noon sky. For a time, it overshadowed its more famous cousin completely, dazzling the world with a glorious unplanned spectacle before fading back into obscurity. It serves as a reminder that the cosmos is full of surprises, and that sometimes the most magnificent displays are the ones we never see coming, silent wanderers that arrive unannounced to briefly share their glory. Many asteroids that appear to be single points of light are actually contact binaries, two worlds resting against each other. Roughly 15% of near-Earth asteroids, larger than roughly 600 feet, might be these strange bilobed worlds. They likely formed when binary asteroid pairs slowly lost orbital energy over eons, gradually spiraling closer and closer until they gently touched and remained that way, held together by their meager mutual gravity. They look like snowmen in space, or giant cosmic peanuts, drifting through the void as inseparable pairs that have found a permanent, quiet resting place against one another in the vast loneliness of the dark. Drilling into the Chicxulub crater, the site of the dinosaur-ending impact, revealed a stunning geological structure called a peak ring. When that massive asteroid struck, the solid crust of Earth behaved briefly like a liquid, rippling violently outward before snapping back inward. The center of the crater rebounded upwards, rising miles into the sky like a transient mountain of molten rock, before collapsing back down and outward to form a circular ring of rugged hills inside the main crater rim. This entire violent fluid process happened in mere minutes, freezing solid to leave behind a perfectly preserved gargantuan ripple in the Earth's bedrock, a silent geological scar that tells the story of unimaginable energy unleashed in a single cosmic instant. Carbonaceous chondrite asteroids are among the darkest and most ancient objects we can study directly. These asteroids are rich in carbon, making them as black as charcoal, and they have remained almost entirely unchanged since the very first days of the solar nebula. Unlike rocks on Earth that have been melted, crushed, and recycled by geology, these dark stones are pristine libraries of the original dust that formed our system. They often contain tiny white inclusions of calcium and aluminum that are the very first solid minerals to ever condense out of the hot primordial gas. Ancient motes of matter that have been waiting patiently in the dark for over 4.5 billion years to tell us their origin story. Comets are not just passively moved by gravity. They can also steer themselves with tiny icy thrusters. As sunlight heats the comet's rotating surface, jets of gas erupt not uniformly, but from specific active regions, often pushing against the comet nucleus like rocket engines. These non-gravitational forces can slightly alter the comet's predictable path, speeding it up or slowing it down in ways that pure gravity cannot explain. It gives these icy wanderers a semblance of agency, as if they are not merely falling rocks, but active vessels gently piloting themselves across the currents of the solar system using ancient, frozen fuel. Deep in the asteroid belt, some rocks are spinning so fast that they are slowly shedding their own equators into space. When an asteroid is a loose rubble pile, rather than solid rock, spinning it too fast creates a magnificent, slow-motion landslide where rocks drift right off the surface into orbit. This process can eventually create a small moon from the asteroid's own body, or even cause the parent body to gently split entirely into a new binary pair. It is a form of quiet, rotational reproduction, where a single asteroid, given enough time and sunlight, can blossom into two, populating the belt not through violent collisions, but through a gentle spinning separation. Iron meteorites found on Earth are incredibly durable survivors that can last for millions of years on our surface, while stony meteorites tend to weather away into undistinguished dust relatively quickly once they land in our wet, active environment. Iron meteorites are immensely tough chunks of nearly pure planetary core material. Some have been found that fell literally millions of years ago, sitting patiently in deserts or buried in ancient ice, waiting to be discovered long after their rocky siblings have crumbled away. They are heavy, persistent echoes of shattered worlds, enduring almost forever as silent, metallic sentinels on the surface of a world that is not their own. The sheer cold of a comet nucleus far from the Sun is deeper than almost anything naturally occurring on Earth. When a comet is cruising through the aphelion of its orbit, far beyond Neptune or in the Oort cloud, its temperature drops to only a few degrees above absolute zero. In this profoundly deep freeze, all chemical reactions cease entirely, and atoms themselves barely vibrate in the utter stillness. It is this unimaginable cold that makes them such perfect time capsules, locking their primordial contents into a state of perfectly suspended animation that can last for the entire multi-billion-year lifespan of the universe without ever changing a single molecule. We can see the detailed shapes of near-Earth asteroids even without sending spacecraft, by using giant radar dishes, by bouncing powerful beams of radio waves off passing asteroids and listening for the faint echoes that return minutes later. Astronomers can build incredibly detailed 3D models of these distant rocks. These ghostly radar images often reveal strange shapes, craters, separate moons, or even boulders resting on their surfaces, all while the object is millions of miles away in the dark. It is like reaching out with an invisible hand of light to gently feel the contours of a face we cannot see with our eyes, revealing the hidden texture of the wandering dark. Much of the comet dust that trails behind these icy visitors eventually spirals inward to become part of the Sun, due to a subtle drag force from sunlight itself, known as the Poynting-Robertson effect. Tiny dust grains left by comets slowly lose orbital energy over thousands of years. They gradually spiral inward in a grand, slow funeral procession, eventually vaporizing as they get too close to our star. It means the Sun is constantly consuming the ancient, dusty history of its own system, a grand, fiery final resting place for the tiny, wandering specks that have spent eons traveling through the cold, celestial void. If you could stand on the surface of a comet as it approached the Sun, you would witness glorious towering jets of gas and dust erupting around you. Unlike volcanoes on Earth that spew molten rock, these cryovolcanoes would be silent, majestic geysers of sublimating ice, shooting columns of glittering frost miles into the black sky. The ground beneath your feet might gently tremble as deep pockets of gas heated by the distant sun suddenly found release, turning the entire comet into a dynamic, active world. It would be a breathtaking, surreal landscape of shifting shadows and brilliant, illuminated plumes, a frozen world slowly coming alive in the warming gaze of its parent star. The famous Tunguska event was likely not a unique occurrence, but part of a natural, ongoing cosmic cycle. While it is the only such massive event in recorded human history, geological evidence suggests similar airbursts have happened countless times over Earth's long life. We find strange microscopic diamonds and rare forms of shock-melted minerals in sediment layers around the world, silent testaments to ancient days when the sky briefly roared with fire. It is a humbling reminder that our planet exists in a busy cosmic neighborhood, and that these dramatic, energetic visits are just a normal part of a planet's long and varied life story. Some comets are true interstellar interlopers, visitors from other stars that race through our solar system once on open, hyperbolic paths. While most comets were born here, some models even suggest that a few such objects might one day be captured by our sun's gravity and become permanent members of our comet family. They would have formed around alien suns, perhaps with different chemical compositions, before being ejected to drift through the unimaginable vastness of interstellar space for millions of years before finding a new home with us. They are the ultimate immigrants, carrying the secrets of distant, unknown star systems right into our own celestial backyard for us to study. The asteroid Apophis, named after the Egyptian god of chaos, will provide a spectacular show for humanity in 2029. On Friday, the 13th of April, 2029, this massive rock, roughly as wide as the Eiffel Tower is tall, will glide silently across our sky, becoming bright enough to be seen with the naked eye from Europe, Africa, and Asia. It will pass harmlessly within the ring of our geostationary satellites, a remarkably close shave in cosmic terms. Rather than a harbinger of doom, it will be a magnificent, once-in-a-millennium opportunity for the entire world to look up together and watch a mountain float peacefully through the heavens above our heads. Some models suggest that comets may have once possessed liquid water interiors deep beneath their frozen, insulating crusts. Radioactive elements trapped inside a newly formed comet would have released heat as they slowly decayed over millions of years. In large enough comets, this internal warmth might have been enough to melt some of the deep ice, creating hidden, dark oceans that existed for eons before eventually freezing solid again as the radioactive fuel ran out. It is a staggering thought that these seemingly dead balls of ice might, in theory, once have been active, diverse worlds with their own hidden internal seas, drifting secretly through the cold vacuum. The Great Comet of 1811 was visible to the naked eye for an incredible 260 days, a record that stood for nearly 2 centuries. It was a truly gigantic comet, with a coma that was famously larger than the sun itself, and a magnificent tail that stretched across the sky. It hung in the heavens for nearly 9 months, a persistent, silent companion to an entire year of human history, influencing art, literature, and even the vintage of wines, with comet wine from that year being highly prized for decades. It shows how a single celestial visitor can become deeply woven into the cultural fabric of a civilization, a shared memory that lasts long after the object itself has faded back into the dark. Many asteroids are not just solitary rocks, but rubble piles that are incredibly porous, like celestial sponges. Missions that have bombed or landed on these asteroids have found them to be surprisingly low density, often with 40% or more of their volume being just empty space between the jumbled rocks. They are like vast floating gravel bars, ancient accumulations of debris that have drifted together so gently that they never compacted into solid stone. It means that if you tried to push one, it might absorb the energy like a giant bag of sand, rather than bouncing away like a solid billiard ball. Jupiter's gravity is so immense that it can sometimes tear passing comets completely apart without them ever even touching the planet. This process, known as tidal disruption, happens when the gravity pulling on the near side of a comet is significantly stronger than the gravity pulling on its far side. This differential force can overcome the weak icy glue holding the comet together, silently pulling it into a long chain of separate fragments, like unstringing a necklace of pearls. It is a majestic display of pure gravitational power, capable of effortlessly disassembling a world just by being near it. The Stardust spacecraft returned samples of comet dust that contain minerals which can only form at extremely high temperatures. This was a shocking discovery, as comets are thought to form in the coldest, outermost reaches of the solar system. Finding these fire-born minerals frozen inside them implies that the early solar nebula was incredibly turbulent, with material from close to the hot young sun being flung violently all the way out to the icy edges where comets were being born. It paints a picture of a grand, chaotic cosmic mixing bowl, where every part of the system shared ingredients with every other part before settling down into its current quiet order. Asteroids can have their own tiny moons, and some even have two distinct moons orbiting them in a complex dance. We have discovered several triple asteroid systems, where a main central rock is orbited by two smaller companions. These miniature solar systems in their own right are marvels of gravitational balance, demonstrating that the same laws that govern planets and stars apply equally well to humble rocks. They drift through space as a complex, interrelated family, a tiny, harmonious system of worlds endlessly circling one another in the vast, quiet dark. The famous Rosetta mission ended with a deliberate, gentle, slow-motion crash onto the surface of Comet 67P. After 2 years of incredible science, orbiting and studying the comet as it rounded the Sun, the spacecraft was slowly guided down to the surface in a final one-way journey. It continued to send back unbelievably detailed close-up images until the very last second before contact, finally coming to rest forever on the dusty, icy world it had come to know so well. It now rides silently on the comet, a tiny human artifact that will continue to loop around the Sun for millions of years, a permanent monument to human curiosity. Some rare meteorites found on Earth are actually pieces of Mars or the Moon that were blasted off by asteroid impacts. When a large enough asteroid hits Mars or the Moon, it can launch debris with such tremendous speed that it escapes that world's gravity entirely and enters orbit around the Sun. After drifting in space for millions of years, these wayward rocks can sometimes cross paths with Earth and fall as meteorites, delivering us free samples from other major worlds. It is a wondrous realization that the rocks in a museum display case might have once been part of a Martian volcano or a lunar high plain, traveled millions of miles, and landed here just for us to find. The Kuiper Belt is estimated to contain hundreds of thousands of icy objects larger than 100 kilometers across and trillions of smaller comets. It is a vast, sprawling frontier of incredible abundance. A second, much larger asteroid belt made of frozen volatiles instead of rock. Despite its immense population, it is so incredibly huge that the average distance between these icy worlds is staggering, making it mostly empty space. It is a vast, quiet, and lonely reservoir of ancient worlds, slowly wheeling around the sun in the eternal twilight, far from the warmth and light of our inner system. In the distant future, humanity might use asteroids as gigantic, naturally occurring spaceships for long journeys. Some visionaries imagine hollowing out a large solid asteroid, spinning it to create artificial gravity on the inside, and using its vast bulk as radiation shielding for a generation ship. It would be a world unto itself, a self-contained island of life, traveling slowly but safely through the endless interstellar void towards distant stars. It is a beautiful dream of turning the ancient debris of our own system into the majestic vessels that will one day carry our descendants to new homes across the galaxy. Comets are often described as time machines because their deep interiors have not changed since the dawn of the solar system. While their surfaces might be altered by sunlight, the material deep inside their frozen cores has remained perfectly insulated and untouched for over 4.5 billion years. By studying this pristine material, we are effectively looking directly back in time to the very cloud of gas and dust from which we all emerged. They are the ultimate preservers of our deepest history, silent, frozen librarians, holding the very first unmodified books ever written about our cosmic origins. One idea is that the Great Red Spot on Jupiter may be continuously colored by complex organic compounds delivered by comets and asteroids, though this has not yet been confirmed. While the storm itself is a churning atmospheric feature, its distinct reddish hue might be maintained by a steady rain of tholins and other chemicals from incoming cosmic debris that get caught in the giant vortex. It suggests a beautiful, subtle connection between the smallest wanderers and the largest planet, where the tiny, invisible rain of ancient comets helps to paint the most famous storm in the solar system. Even today, amateur astronomers with modest backyard telescopes still regularly discover new comets and asteroids, while massive automated surveys now find most near-Earth objects. Dedicated individuals patiently scanning the twilight skies still occasionally spot a faint, fuzzy intruder that the big machines missed. It is one of the few remaining fields of science where a lone, passionate observer, armed only with patience and a love for the dark, can still make a genuine, lasting contribution to human knowledge, forever attaching their name to a piece of the eternal heavens. The Yarkovsky effect, which moves asteroids with sunlight, can be used by humanity to gently deflect hazardous rocks. Instead of using nuclear weapons or violent impacts to stop an incoming asteroid, we could potentially just paint one side of it white or black. This would change how it absorbs and radiates heat, altering the natural Yarkovsky drift and causing its path to slowly, safely bend away from Earth over several years. It is a wonderfully elegant, peaceful solution, using the subtle, gentle pressure of light itself to steer mountains and protect our entire world. Comets can sometimes have anti-tails that appear to point directly towards the sun, defying apparent logic. This is usually an optical illusion that occurs when Earth crosses the plane of a comet's orbit. We see the wider, flatter dust trail edge on, and due to perspective, part of it appears to project forward in front of the comet's head. It is a delightful trick of cosmic geometry, a reminder that our view of these three-dimensional wanderers is always shaped by our own particular ever-changing vantage point in the grand celestial dance. Nearly every atom in your body, from the calcium in your bones to the iron in your blood, has likely been part of countless comets and asteroids before it was you. Before the Earth formed, the atoms that now make up you were drifting in the vast solar nebula, locked inside tiny grains of dust and ice that clumped together to form the first rocks. These rocks built the Earth, delivered its water, and seeded it with chemistry. You are, in a very real and poetic sense, a temporary, conscious collection of ancient cosmic debris, a brief, wondrous moment where the silent dust of the universe stood up, looked around, and marveled at itself. And so, our journey through the wandering ancient world of comets and asteroids comes to a gentle close. We have traveled alongside these silent voyagers, from the fiery birth of our solar system to the quiet, frozen depths of the Oort cloud. We have seen them not just as rocks and ice, but as storytellers, carriers of life's ingredients, and sculptors of worlds. They are the persistent, drifting memories of our celestial home, reminding us that we are part of a vast, dynamic, and incredibly old system that is still slowly evolving around us. If you're still awake, you can simply let your thoughts drift with the quiet music, like small worlds gliding along their orbits. And if your eyes are heavy, let the stories of comets and asteroids fade softly into the background as you drift into sleep. Sleep well. Good night.